Good afternoon, everyone. My name is Awele Oguejiofor, and I'm a Business Development Officer at the Canadian Institute for Cybersecurity, CIC. I would like to thank you all for joining us for our first webinar series to celebrate the 2022 Cybersecurity Awareness Month. October marks the Cybersecurity Awareness Month, an internationally recognized campaign to inform the public of the importance of cybersecurity. Throughout the month, we'll be featuring 12 experts who will be sharing their wealth of knowledge with us, including today's speaker. Kindly listen to these talks to learn more about being secure online and how to protect your personal information, your devices, and organization's data. Just a quick housekeeping rule to start off. Our speaker today has 20 minutes for her presentation, with an additional 10 minutes for Q&A from the audience. Please feel free to type your questions in the Q&A box while the presentation is ongoing or at the end, and I'll read out your questions. Now, let's jump into our content for today. I'd like to introduce Dr. Windhya Rankothge. Windhya is a postdoctoral fellow at the Canadian Institute for Cybersecurity, CIC, located at the University of New Brunswick. She received her PhD in Information Technology and Communication in 2017 from the University of Pompeu Fabra in Barcelona, Spain. Windhya was a visiting researcher at the IBM International Technology Alliance and Imperial College London in 2016 and 2017, respectively. Her research interests are in the following areas: network security, cybersecurity, and software-defined networks. Windhya has published her research work in numerous journals and conferences, and she is an IEEE Senior member. Currently, she serves as the chair of IEEE Women in Engineering New Brunswick Section. Her presentation today is titled Effects of Networking Evolutions Towards Cybersecurity. Dr. Rankothge, the floor is yours, please.
Thank you very much, Dr. Awele, and good afternoon, everyone. So it's nice to have you all on board for the very first webinar that is going to happen for the Cybersecurity Awareness Month webinar series. And I will start this webinar series by discussing with you about computer networks and how they have been evolved since its inception, and also how they are affecting the cybersecurity and the challenges they are bringing us to the cybersecurity world. Let me share my screen first. I hope you can see my screen. Okay, thank you. So, as we all know, computer networks or networking, the first thought that comes into our mind is internet. Internet is possible because of the computer networks that we have today. Computer networks connect thousands of computers together using different technologies, different media. It can be wired media such as Ethernet or fiber optics. It can be wireless media such as Wi-Fi, cellular, and maybe even the satellite. Whatever the method we are using, internet is very important for us today, for our day-to-day lives. Not only for our professional work, but also for our social engagements. We have a lot of social networks, and also for our education purposes, we have online platforms that we can learn thousands of things. For all these things, most of the people use internet in their day-to-day lives. According to these statistics, around 5 billion people are using internet. That means around 63% of the total population in the world. And percentage of users accessing internet via mobile phones, simply like us, 92.4%. So all of us are using internet. It can be through your laptop, it can be through your tab, or it can be through your simply mobile phone. Because of this internet, there are several security challenges has been introduced for cybersecurity professionals. as cybersecurity professionals or as anyone who is in the cyberspace or internet, you might have heard these terms: malware, a malicious software, which pretends to be doing something useful, but it's doing something harmful to your computer, to your network, or to your device. And there are several web-based attacks. Attackers attack your computer, attack your software, attack your network through internet or through web. And phishing, kind of a social engineering attack. Attacker pretends to be someone that is authorized to collect your confidential information or collect your useful information and make you to reveal your information. So there are other types of attacks that happens through network or through internet, such as web application attacks, spam, denial of service attacks. So all these are simply because of the internet that we use for our day-to-day operations. And this triangle or pyramid shows how bad or how harmful network security threats are. Since we use thousands of devices these days, each and every one of us, we have more than one device connecting to internet. We connect our laptop, we connect our mobile phone, we connect our tab. So each of us connect at least 2 devices to internet. So there are thousands of devices. All these devices bring security challenges. That's why the more security challenges or the more focus on cybersecurity is at the bottom of this pyramid, that is the device-centric security. Next level, we have network-centric security, because all these devices are connected with each other using a network, computer network. And then we have software or system-centric security, which enables networking and connecting all these devices. Then we have our data or application-centric security. And finally, we have user-centric security. In today's discussion, I will focus more on network-centric security, how this network has been evolved since its inception, and what are the security challenges that they have brought into the cybersecurity world. So I'm going to talk about 2 types of networks: data networks and mobile networks. In data networks, we share our data in the form of like images, text messages, video, audio. And in the mobile networks, of course, we share any type of data networks, but in mobile networks, especially, we are connecting through mobile networks like cellular phone networks. So the outline for today is how data networks have been evolved and how mobile networks have been evolved. And especially for data networks, I'm going to talk about 2 new hot topics or 2 concepts: software-defined networks and network function virtualization. And in mobile networks, I'm going to talk about 5G networks. Since there can be audience or participants who are new to these topics, I will introduce the concept first, its advantages, why we are using these new concepts, and at the same time, what are the cyber threats that they are introducing to the cyber world. So in traditional networks, we have big boxes that help us to connect several computers together, such as switches, routers. They come as big hardware boxes, and these hardware boxes, they do 2 things. First, they decide how to send your packets. It's kind of a logic or algorithm. If it is a switch, it's the switching logic. If it is a router, it's the routing logic. It's an algorithm. Once it is decided how to send your message or how to forward your packet data, then the actual forwarding happens. That actual forwarding is a hardware process which involves several circuits or switches. So both of these, hardware part and the software part, are integrated to one hardware big box, and software, the logic is running on top of it. And when you buy it, you buy one box. Since they are coming as vertically integrated, it's a little bit difficult to do new things, do innovative things, and change things. So as I mentioned, there are 2 parts happening or 2 processes happening. the control part or the software part, the decision, which path to take for a packet, which port to use, or whether the packet should be dropped, the decision, the logic or the software, that is called control plane of the network. And typically they are realized as software using a routing protocol or firewall software. So that's the control plane. And then the actual hardware part, the actual forwarding or dropping of the packet, typically realized by hardware. It can be a circuit, it can be a switch. So traditionally, these two, control plane and data plane, comes vertically integrated as a big box. But with software-defined networks, the networking professionals, they decide to separate these two, control plane and data plane, and take out the control plane, which is the software, and install it as simply as a software, maybe in a computer, maybe in a server. If the network is very big, you can use a server which has more power, more memory, and run the software. If it is a simple network, you can simply install it in a computer, the control plane. So the control plane, which is a software, you can run on a general purpose hardware like a computer or server, commodity computers. And what left in the hardware box, the switch or router, is the real hardware. So it's simply forwarding the packet. No software part there, no decisions taken, nothing processed there, simply forwarding the packet. So now we have separated the control plane and the data plane, and it brings this architecture into the picture. We have at the end, the bottom, we have switches or routers, simple hardware doing the forwarding. And we have SDN controllers or software-defined network controllers, which runs the algorithm. It can be different algorithms to balance the load or to drop the packet or to forward the packet. And we call them as controllers, depending on the language that you use to write the software program. It can be C++, it can be Java, it can be Python. Different controllers are there. For an example, Floodlight is a Java-based controller. Knox is a C++-based controller. Based on the program you use to write the software, you can use different controllers. And then you have the actual program that you write, which run on top of these SDN controllers. It can be a firewall program, it can be a load balancing program, it can be simply intrusion detecting program. So any program you can run on top of the controller with your preferred language. You're writing simply a software. And we have southbound API, which is an open interface that process the communication between switches and routers and the SDN controllers. So we have a standard southbound API, which is known as open flow, and it can be used in any Ethernet or IP or TCP-based networks. However, if we are using open flow API as the southbound API, the switches and the routers that we are using in the network should be open flow enabled and open flow compatible. Northbound API is not standardized because it depends on the language you're using. If you're using Java, as I mentioned earlier, you can use Floodlight controller, and then the northbound APIs will be Java-based. If you use C++, you can use Knox, and it will be C++-based APIs. So this is the basic SDN architecture. And of course, SDN brings a lot of advantages. Now we have simplified the network, as the physical part is there in the network, but software part has been taken out. So the network management is easy. You can you can write your program based on your language preference and run it easily. And you can run this as a cloud application in the cloud. So it reduces provisioning time, easily programmable, scale up and down easily. So any cloud advantage, you can gain them. And no topology limitations. The network can be very large or very small in different type of shapes. You can easily use SDN concepts. Even though SDN brings a lot of advantages, at the same time, SDN brings a lot of challenges. Now we have divided control plane and data plane. Data forging can happen. That means you can have fake data. You can have change data, modified data in both control plane and data plane. Attacker can attack both of these planes. An attacker can change the software programs and divide the traffic using both planes, because now we have the software running on the server. Attacker can attack the server and change the software. And also software exploits, any exploit in software, like any loophole, any vulnerability in the language, programming language itself, can be used by the attacker to attack the network. Flooding attacks, attacker can send thousands of packets and make it a denial of service attack. That means the legitimate users can't have the access to the network. An attacker can spoof the identity and pretend to be someone authorized in the network and use the SDN network. Attacker can exploit the APIs that we use, especially OpenFlow API or any northbound APIs that we are using. And also attacker can sniff traffic by running a sniffing software in the server and check what are the data or what are the things going around the network. So of course, SDN brings a lot of advantages, but at the same time, SDN brings these threats into your network. Now with SDN, we have another concept called network function virtualization, or NFV. NFV is running your network functions. It can be a firewall, it can be a virtual private network, it can be a NAT, it can be a router, it can be a CDN, or it can be intrusion detection system. You can run these as software in the cloud and virtualize these network functions. So virtual appliances, router, load balancer, intrusion detection system, firewall, they run as virtual appliances like software in general purpose servers. So this is the infrastructure or the architecture of network function virtualization. We have the infrastructure for the virtualization. It can be a server, it can be your normal computer. And you run your virtualized network function, the software on top of that, load balancer, hard firewall, intrusion detection system, any network function. And you have NFV management and orchestration part, which manages all these network functions. Of course, once again, similar to SDN, it brings a lot of advantages like flexibility, agility, and also cost-wise, it's very effective. And you can develop these network functions easily and deploy them easily. However, they also bring a lot of threats. First of all, since we are running these network functions in servers, the attacker can abuse these hosts, or attacker can attack these hosts and gain the power of these hosts. And since network function virtualization is generally used hand in hand with SDN, software-defined networks, it also brings all the problems with SDN. And if there are any vulnerabilities, loopholes in virtualization mechanism, it also introduces threats to the network. So as similar to SDN, even though NFV brings a lot of advantages, they themselves bring a lot of threats as well. So if you are interested on any of these are very hot topic for research work, especially any person who is using networking. You can research about these even for your general day-to-day access. Then we come to the mobile networks. Mobile networks, you might not remember, like we started from first generation 1G, 2G, 3G, 4G, and 5G. So we are in between. Some people use 4G and some people use 5G these days. So we are in between this, and also 6G has been introduced. So the speed of the network has been increased from 2.4 kilobits per second to now we have almost 1 gigabits per second speed. And if you look at the 5G network architecture, it can be divided into three components. Data networks that we discussed earlier, we can use SDN or NFV here. And then we have radio access network, actual wireless part, and the core network, which connects all these wireless devices to the data network and access internet. So radio access network, it actually connects all your wireless devices together. Smart homes, smartphones, laptops, smart energy, healthcare, cars, and everything. So as you see, local servers are there, and we connect to the local servers, and local servers connect with each other and have the central server. In 5G, the two special characteristics. Cells are very small. It's millimeter wave, or we have wave frequencies, and connection range is very short. And also the cells of 5G, we call them as macro cells. They use multiple input, multiple output antennas, MIMOs. When it comes to the core network, in the core network, we can use the software-defined network concepts that we discussed earlier, and also network function virtualization concepts. We can virtualize the network functions, and we can divide the core network into different slices and connect different components of the network separately. For an example, you can have slice 1, which serves high bandwidth applications. Slice 2, which serves low latency applications. Slice 3 serves low power devices, and others, the last slice, any other application. Likewise, you can divide your network into slices and separate them based on your requirements. So with 5G, there are several advantages, like we can provide up to 10 gigabits per second data rates, and a very small 1 millisecond latency, 90% reduction in network energy usage, which is very from the environmental perspective, very effective, and up to 10-year battery life. So all these advantages are there with 5G networks. However, there are several cybersecurity challenges also being introduced with 5G. According to ENISA, European Union of Cybersecurity, these are the major cyber threats. Malicious mobile nodes, because attacker can create its own node, a mobile node. It can be a mobile phone, it can be a laptop, or it can be any mobile device, and create malicious software or malicious hardware and attack the network using that. And there are MAC layer attacks, like MAC address spoofing and making the MAC layer congested and jamming the network. Since we are using SDN or NFV in the core network, SDN-based attacks and NFV-based attacks can be there. And most of the devices that we connect these days are IoT devices, which connect to the network time to time to sense the network, to send data, general IoT sensors. They can have their own threats, IoT threats, and at the same time, physical threats. Physically, a person can go and harm the networking devices. So as I mentioned earlier, even though 5G brings a lot of advantages to the network, it also brings a lot of threats to the network. So all these are hot topics these days. So most of the people are doing researches about these, how we can avoid these threats and so on. So if any of you are interested, you can look into more details of these different threats. So I think I have taken the 20 minutes that I had. So I talked about two different aspects of networking or evolution of networking, especially targeting data networks and mobile networks. I discussed about the hot topics of data networks these days, software-defined networks, which we separate the control plane and data plane, and also network function virtualization, where we run network functions as a virtualized entity, and also 5G networks. All these are very useful and very familiar to us, because every day we use these even though we don't realize them. Whenever we connect to the internet, whenever we connect our laptop or mobile phone to the internet, we are using these networking concepts. So these are my references for this webinar. And if you have any questions, I would be happy to answer your questions.
Thank you, Dr. Windy, for the wonderful presentation. We have a couple of questions here. Do you want me to take all of, anyway, I could start with this one first. Then,
yeah, sure.
The first one is, can you recommend an SDN controller for someone starting in SDN security?
Yes, sure. That's a good question, actually. As I mentioned earlier, SDN controllers are like different based on the language, programming language you are using. So if you are someone familiar with Java, you could use Java-based SDN controllers, Floodlight. If you are familiar with C++, you can use Nox. If you're familiar with Python, you can use POX or Rui. But if you are very new to these controllers and if you are especially focusing on SDN security, I would suggest starting with Python-based controllers like POX or Rui, because Python is a very basic programming language, but you can do wonders with Python. Before moving to complex or like complicated programming languages like Java or C++ or C#, you can use Python, and you can start with basic programming for security. So I recommend POX, POX, or Rui, RYU. You can start with these two. These are research-oriented controllers, so they provide a lot of libraries, a lot of examples, so that you can try these examples and get a touch or get a flavor of SDN security.
Okay, we have two more questions here. I don't know if you could take them quickly. The first is, can you give a practical example of adopting software-defined networks? And the second is, how is industry responding to threats with network evolutions?
Yeah, for the first one, practical implementations, actually now the big companies, Amazon, Google, IBM, everyone is moving to SDN. Especially IBM, Google, they have almost transformed their networks into SDN-based networks, especially because of the easiness separating the software and hardware part and running software controllers easily on the servers. So they have finished most of their transformations. Since these big companies are moving, other like small and medium companies also trying to move their networks into software-defined based networks. But one challenge they are facing is the switches and routers should support OpenFlow. That means if your normal software and normal switches and routers are not supporting OpenFlow, you might have to buy new devices. So it might cost a bit at the initial stage. That might be a bit of challenge for small and medium enterprises. But because of the advantages they are providing, thinking about long term, most of the big industries, Amazon, Google, they have already started their transforming and almost done. The second question about the security, responding to security, there are a lot of research going on how network evolutions are affecting the cyber world, especially in terms of SDN, NFV, and 5G. And they have you might have heard the terms of SecOps, DevOps, TechOps, NecOps. All the operations in organization which are related to networking, security operations, network operations, DevOps, they all are integrating security as well as network evaluations to their processes and for their thought processes, and doing research work on these aspects and adapting security solutions, mostly the software solutions, because now you can run them on normal servers and integrated with SDN network easily. So they are finding it difficult because new threats are being introduced, but at the same time, since you can manage them with software solutions, they can easily write software solutions as programs and run them in security. So I think industry is responding well, and they're taking this as a very serious problem, and they're trying to find solutions for this.
All right, thank you very much for your response to the questions. This brings us to the end of our first webinar, and we hope to see you tomorrow at noon for the second webinar. So thank you, Dr. Rankothge, for the wonderful presentation. And bye-bye to everyone.
Thank you. Bye.